Cat B. We have a silk transparent tube, okay, filled with a liquid. So liquid and contains a small ball. The tube is inclined and its lower end is attached to a motor, right, such that the tube traces a conical surface. Investigate the motion of the ball as a function of relevant parameters. Okay, right. So since it's Cat B, I'll say a bit more. Some of the things that you can vary will be omega. Okay, right. That is the rate at which you rotate the tube. Second is the angle theta. Okay, right. And then the third thing is the density of the liquid. Okay, right. In particular, density of the liquid relative to the ball, right? Because right here we are interested in looking at the floating object, right? So, yeah. So you don't just vary the density and then with all the density falling below the density of the ball. Yeah, you want to go higher than the density of the ball. Size of the ball, okay, small size, big size. Okay, I would suggest that you start with a ball that is that fits the tube nicely. Okay, right. Not touching the side but small enough. Sorry, big enough. Why? You know why? Okay, we'll look at some of the ideas. Okay. Oh. Okay. This one maybe the teachers can bring you all through. Okay, but I'll just give one statement. Remember Archimedes' principle? Right? The buoyant force is equal to what? Equal to the weight of the fluid displaced. Okay? That's what all this mathematics is saying. That's it. Okay, so I'm just putting it in a very scary manner. Okay? Right? But this is all it says. Okay? The reason why the reason why I need to do this is because, right? Unfortunately, it's rotating. So we are in a rotating frame. Okay? If we're in a rotating frame, well, I give you some slides on how to derive the formula for rotating frame. Okay? Right, so teachers can bring you all through. Okay, so finally you're going to see this. Right, remember just now, centrifugal, Coriolis, right? And if you can vary the omega, that means you can change omega, then you have another Euler's force. Okay, right? So these are forces associated with what? The rotation. Now what do you see here? You see that, this object here, this is not ordinary multiplication. This is a vector multiplication. Okay, cross product. Right? This product here has a dependence on theta. Just now I said, right, vary theta, right? Okay, vary this angle. Okay, right, you are actually changing that thing. Next, you can see here, right, R here, okay, you'll see this R here is actually the position of the, of the water. Okay, right? So, another thing, what gives rise to the buoyant force? Gravity. Okay, G. Okay, now look at these forces due to the rotation of the rock. They are like gravity. Okay, right? So you can see from here that this system, when you do this, okay, you're actually creating gravity, right? And the G is different at different R. Okay, and you can vary your G. You can vary your theta. You can vary omega. Okay, yeah, right. So so in fact, this problem, if you can crack all those things, right? These few things, crack it and right. These are not I would say these are not the hard things because these are all well known. Okay, so what you need to do is just learn it. Okay, right, and then you will be able to see what are the forces acting on the ball. That will of course determine the motion of the ball. Okay, now there's one basic assumption here. My basic assumption, if we were to take just this equation, we are assuming that the fluid is rigid. Okay, Yeah. In other words, we do not take into account the fluid dynamics. Okay, right? So we can do that if the ball doesn't spin around, right? So that's why I said you create, to begin, right, you experiment. Okay, try balls which are, comparable in size to the diameter of the rod, and to the diameter of the container, of the tube. Okay, don't try a very small one. You try a very small one, then you swirl around, then you will create eddies, and then there will be fluid dynamics, and it will be more difficult. Yeah. Okay. Then you can talk to your Cat A friends. Remember Cat A has the Navier-Stokes equation in rotating frame. Yeah. Okay. So that's why I put this Cat B. Yeah. Okay. Clever. Right? Okay. So if you're going to consider fluid dynamics, then you can consult your Cat A buddies. Okay, I think I'll take a break here. Who's next?
Alright, you want to go to a washroom, please go ahead. Whitman will come now and share this problem.
Attendance, please come and sign. It's very important because I will be sending the documents to your school. So if you don't sign, I won't know who to send to.